Okay, your ISN notes, problem number 1. Do you see that there's a negative sign under the radical? Negative 6 would be equal to 6 times negative 1. Is that true? Negative 6 would be 6 times negative 1. A property of square root says that if I have two numbers multiplied together under the radical, I can change that into two separate radicals. And then I can reduce it. Well, is 6 a perfect square number? Is it perfect? So, if it's not perfect, then you do the birthday cake on it. How many times does 2 go into 6? 3 goes into 3, and I don't know why I put that on there. Okay, and did I find any pairs? That means that this does not reduce, but this does. What is the square root of negative 1 equal to? I. And so this is times I. That's equal to I. Now, we usually don't write it that way. We usually write the I out in front. I don't know why I changed it to a 36. That was odd. When you have an I and a radical in the same answer, you usually put the I in front of the radical. Now, you got that much? Is this the same problem? Is this equal to that? What's the difference in this problem? No, this is not true. What is the difference between the first problem and the second problem here? If the negative is on the outside of the radical, that does not give you an I in the answer. If the negative is on the inside of the radical, it does give you an I in the answer. The next one we're going to do is example number 3. We're going to skip example number 2. This is equal to 45 times a negative 1 under the radical. This is equal to 45, the square root of 45, I should say, times the square root of negative 1. 45 is not a perfect square number, so I'm going to do the birthday cake on it. And so 2 will not divide into that. 3 divides into that 15 times. 3 divides into 15. And 5 divides into that. Now, the one mistake I saw people making on a birthday cake the other day is not using the smallest possible number when you start your birthday cake. Sometimes when you do that, you miss one of the prime factors. That is one of the good things about the birthday cake is you always start with 2, and then 3, and then 5, and if you always start the same way, you're less likely to miss a factor that you need. Okay, so now I have a pair of 3s and a 5 left over. And this is equal to I. And that's the order we usually write our answer in. The whole number if there's a pair, and then the I, and then the radical with the leftover numbers. So, the only difference in what we were doing the other day is if there's a negative sign under the radical, there'll be an I in the answer. So the next one we're gonna skip 4 and look at 5. So, just like when we did this before, if there's a number out in front, we're going to leave it out in front. We're going to come back to it later. And so this would be the 3 out in front, And that would be equal to the square root of 20 times the square root of negative 1. 20 is not a perfect square number, so I come down here and do the birthday cake. 2 will go into 20. 2 will go into 10. The reason I do the birthday cake is to find the pairs. There's a pair of 2s. And there's a 5 left over. There is also a 3 out in front. There is also an I that represents the square root of negative 1. So, question, 3 times 2 is 6i square roots of 5. The next one I want to look at is problem number 6. For problem number 6, we'll get to the 4 out in front in a moment. You write the 24 down. You do the birthday cake on the 24. The reason you do the birthday cake is so that you can find the pairs. Do I have any pairs? I have a pair of 2s and a 2 times 3 left over. And I also had a 4 out in front. So the 4 times the 2 out in front multiplies together, and the 2 times the 3 inside the radical multiplies together. Why doesn't this problem have an I in it? The other problems had an I in it. If it does not have a negative under the radical sign, it will not have an I in the answer. And some of you had a little bit of difficulty on the test with these problems that had variables in it. I can't really do a birthday cake on the variables. All I'm going to do is expand the variables. Isn't that what x to the third power means? And I am still going to do the same thing once I have it expanded. I'm going to look for pairs. There's a pair of 3s, and there's an x left over. Again, why doesn't this have any i's in the answer on this one? There was no negative sign under the radical, so there's no I in the answer. 9 is the next one I'm going to do. So this is going to equal 12 times negative 1 times x squared. So the first thing I'm going to do is a birthday cake on the 12. 2 will go into 12, 2 will go into 6, and then 3 will go into 3. The reason I do the birthday cake is to find the pairs. There's a pair of 2s and a 3 left over. That's for the 12. What about this? That makes an I. This has a pair of x's. The pair of x's comes out in front. That's your final answer. And I believe it's usually written in this order: whole number, variable I, and the radical is last.